I'm Guillermo Sapiro. The goal of my talk, which hopefully is going to come up, is to show you how engineering has changed. So if you're sitting next to your parents or friends that have done any degree in engineering the time I did, I graduated my PhD about 21 years ago. And engineering has changed a lot. I want to illustrate to you about how we at Duke are basically pioneering in the new way that we should be teaching and doing research in engineering. About 2 years ago, I was in a similar position that many of you are. I got a call from Duke. I was a very happy person at a different university. My family was very happy in a different city. And I got a call. From President Broadhead saying, we would love if you move here. And I wasn't planning, so I was in a similar situation as you are, trying to make a decision. And I came to Duke for a visit, and I fell in love with this place because engineering is different at Duke. I have a position in electrical engineering, in biomedical engineering, and computer science, and that's very common at Duke. You're going to find a lot of faculty that have 3-4 different faculty positions here. It's not that we get 3-4 times the salary. I wish to. We don't get it even 1.1. We get 1. But that shows how we basically travel between departments, and half of my collaborators are actually in the medical school. And when I interview here, so most of you don't know how a faculty interview goes, but you have to meet a lot of people and impress a lot of people and give talks and keep impressing people. And I was walking around campus for 2 days. I met about 20-something people, which is normal when a senior person comes. And I had no idea at the end of the 2 days to which department they belong. And that was beautiful for me. I say I'm basically interviewing for electrical engineering, biomedical. I'm visiting the medical school, and I had to go home to the hotel actually and look who actually is paying their salary, because that's basically what the department, like it was only that. Where do you teach and where do you get your salary from? So I really love that. And after a lot of thoughts with my family, we decided to move here 2 years ago. So what I hopefully at some point, because it was only a 10-minute talk, and I wanted to get questions from you. So I work a lot in image processing. If you use Adobe Photoshop or other products from Adobe, some of my algorithms have been licensed to Adobe, and we have a strong collaboration with Adobe. And some of my students are employees now in Adobe. My other claim to fame is that if you whoever seen images from Mars rovers from the NASA expedition. Okay, so those images are transmitted to Earth with an algorithm that's called compression, just to make it a bit smaller so it doesn't occupy. So NASA stole our patents, but we forgive them. But they basically implemented my algorithm for the NASA rovers. And that was very cool. And the other areas that I'm working right now, and the 2 areas that hopefully I might get to discuss with you, one is brain surgery. So we are developing techniques that are helping brain surgeons. And the other area is early childhood screening for mental disorders. So brain surgery, if we get to see that, the patient that we are going to see, there is a surgery, it's called deep brain stimulation. It has been mostly done for Parkinson patients, about 120,000 of those surgeries around the world so far. And the surgery is very scary. They actually put an electrode in your brain, and they touch an area which is called the subthalamic nuclei, called STN, and they send electric pulses into that area. Not very clear why, but that actually, if the surgery is successful, it actually stops the tremor. It doesn't stop the progress of the disease, although there are consequences on that as well. It's actually stopped the tremor. You hopefully will see, if not, you have to just search for a YouTube video of DBS patients, that the patients enter the OR, Parkinson's patients, like this, and they leave the OR like this. So it's instantaneous, absolutely instantaneous effect. So all of us will say, why not everybody goes to that surgery? It's an expensive surgery, but it's FDA approved, and if you qualify, it's paid by the insurance. It's about $120,000 surgery. And what I haven't told you is that surgery is done awake. The patient has to be awake today for that surgery because the neurosurgeon and the neurologist don't know exactly where they're going in your brain. So they know they have to hit the STN, but they take a picture of your brain with an MR machine, and that STN is not visible in that picture. So it's about driving to Duke without Google Maps, but moreover, driving to Duke where Duke campus doesn't appear in the map. You know it's somewhere in Durham. So you wouldn't dare to do that, and that's how neurosurgeons do surgery today. They actually, every single surgery, not only this, is done with the atlas on a very nice lady that in the 60s donated her brain to science, and they did a CAT, they did histology, and everybody looks at her, and they say, oh, I think you should go left from here and right from here, and that's where we're going to go. Okay? So once again, it's almost like coming to Duke because we are 2 miles from a McDonald's, and that's all the reference you have, and that's how neurosurgeons operate. So as an example of how engineering is changing, we put together a team of a neurosurgeon, a neurologist, a radiologist, and a neuroscientist, and we developed a technique that, if I could show you, without any new dollars in the hospital, so no new hardware, no new nothing, we actually help the neurosurgeon to see inside the brain, and the neurosurgeon targets exactly the area to the point that a robot could do it today. So the patient can be completely asleep, and we sometimes laugh because basically the neurologist will do the planning, and we're doing this about once a week already in the OR. We have done 3 hospitals, and we're working with some of the top people in the medical sciences. So that's an example of something that wasn't so common, but today is very common to put teams like that. So that's one area. The other area is a completely different. So Parkinson, normally we associate Parkinson with an elderly disease. By the way, this operation is FDA approved for Parkinson, essential tremor, dyskinesia, so mostly motor things. It's approved by FDA for what's called humanitarian reasons for depression and obsessive compulsive disorder, which means people that have extreme can apply an FDA because it's still doing research, but the FDA has a special thing that they call humanitarian reasons, that you really need this surgery desperately. So we associate Parkinson with elderly population, and that's a correct association, although we have done patients in their 40s where the first symptoms appear, and that's actually very useful because they don't need to go into so much medication, and the medication actually has tremendous side effects. So this surgery helps them to stay away from strong doses. So about 2 years ago, when I moved to Duke, we got together to work on the other extreme, and we got together with a child psychiatrist, Helen Eager. She basically deals with very small kids, not babies, but mostly from 18 months old to about 4 years. And she's an expert in anxiety disorders and in impairing anxiety disorders. And we started to work together, and since then, that group has grew. I have a very nice picture of our team now. Every Wednesday morning, we meet in Gross Hall, which is a building that has been remodeled for interdisciplinary initiatives. We have the top floor, half about the top floor. And we meet, and about half of us are nerds like me from engineering, and half of them are nerds from the other side, meaning from the medical school. So you get into the room, and you have one child psychiatrist, one professor, Helen Eager, the worldwide expert in autism, Geraldine Dawson, that moved to Duke a year ago, and an MD that actually works. If you were born here and you use Duke systems, he might have been your pediatrician. So he's at South Point. And we meet every Wednesday morning together with all our students, and we're trying to develop tools that will help early diagnosis. And A few of these slides I have on this part are actually beautiful because we presented them to the Board of Trustees last Saturday. So we did a very fancy TED-type presentation to them. What I didn't know until I started working on this is 1 out of 9 children below the age of 4 or 5 have an impairing behavioral or mental disease problem. 1 every 9. Okay? So if Duke has a yearly admission of how much? 1,000? You do the numbers of how many of those kids in a regular, basically in a regular environment might have had some difficulties, anxiety. And when we're talking anxiety, we're not talking about, oh, I'm scared about crossing the street. We're talking about impairing anxiety. So it's about, and of course, Duke population is a very special population. When we talk about 1 over 9, it's epidemiology studies that Helen did in the general Durham population, for example. The disturbing part is most of them, by the way, that's about the same rate as adults. So it appears very early. The disturbing part is most of them don't get any evaluation during early education. So the average diagnosis for autism in the United States is, anybody knows? United States, I'm not talking about Africa. 5.3, 5 years, 3 months. Jerry can diagnose at 18 months or below. And most experts can diagnose at about 1.5 years. So it's about 4 years that we've been, quote unquote, wasting time. It's 4 years that families had to cope with something that they don't understand. And it's 4 years that the child could not have been helped and intervened, and there is a lot of research showing that early intervention helps. Those are the 4 years where we learn almost everything that we need to learn in our life. And similar for other diseases. And I don't want to quote you how expensive that is also for our health system. So we got together and we say, what happens if we develop computer systems that will be able to, hopefully our dream is to become tests that are as simple as tests that you do in the school when they just check your eyesight or your hearing. And I always want to stress that because some people get very upset about this. If you ever got your eyes checked at school, you were never given glasses. You were sent to a specialist. And that's what we want to do. We want to just raise the flag of warning. We're not going to medicate with this technique. We're not going to give you a diagnosis. We're going to, in private, give you a warning. Or we can develop this and have you, because what we're doing now is developing an app that you download, and you're going to be in front of your iPad, and you're going to be watching a movie. That means you're 2 years old, it's going to be watching a movie that has been designed by us, that it's created to create some stimulus and some reaction in you. And the reaction is the type of typical reactions that you expect in normals that, let's say, kids with autism do not respond to that. And then the camera of your tablet, and that's where I enter, is filming you, and it's automatically doing the analysis. So it's saying, you're crying when I was expecting you to be upset, so that's good, you reacted. Or we have your caregivers call you, and you're expected to turn your attention. Every 18 months old, after the mom calls a couple of times, they just turn around. But kids with autism do not turn because they're very concentrated. They have a hard time shifting attention. So we're doing automatic coding of that. And after a few minutes, we give you a result. And the result might say, you should not be concerned. Or the result might say, you know, here is the numbers of clinics in your area, and we recommend that you give them a call. And that can also help the clinic to manage, because Jerry has about a 12 months waiting list right now at Duke. So once again, I want you guys to think where we are. We are in one of the top universities in the country, one of the most. So I don't know if you guys know that this area has the highest concentration of MD PhDs in the country because of Duke and UNC. And tremendous hospital at Duke, and you have a 12 months waiting. So that's 12 months when you're 18 months old, that puts you in 3 years, okay? So it's like you have to make an appointment the day you're born to be able to be seen. And that's unacceptable for us. So we are working very hard. As I said, we meet every Wednesday for entire mornings. We are starting to pilot this in a pediatric clinic in South Point by Dr. Jeff Baker. And members of his team come every Wednesday. And that, I think, says almost everything, because to get 2 hours of time of an MD that, you guys know how much time he gets per child by insurance? I don't want to scare you. 15 minutes. That's what he gets for every child that he needs to check for regular checkups. So we have him for a few hours, which is a privilege. And our goal is, again, to be able to put that together. And unfortunately, that's not, I can show you the system working. Basically, we, on real time, do complete facial analysis, facial expression. We know if you're looking at the screen. We know if you're looking away. And all that can go into your medical records if you wish to do so. You can upload a video if you wish to do so, or you can just ignore us completely and just make that phone call, but never share the data with us. So we're not, there are people out there that say, send me the video, and I will tell it for you. And then you start being scared. We say, no, no, no. We started kind of those ways, and then we realized that the only way to get to everybody in this world, in Durham or in Africa, is to download an app. So we are not asking you any hardware. We're not asking you anything. So I'm trying to be smart, same as we were. I can do brain surgery better. And this is how we started, if I convince a hospital to buy a machine that costs $7 million. I can give you the Ferrari of brain surgery. And that's how we started. We proved that for $7 million, we give you a surgery of your dreams. And then we say, OK, now we prove the concept, how we make it with zero money. And the same we started here. We started with cameras in the room and installing and say, OK, we prove the concept. How do we make it now with zero money, which is what we're doing now? It's just an app, OK? And even third world countries, they don't have internet, but they have Wi-Fi. So they can download the app. And that's where we're going. I think it's beautiful to see both the reaction of a patient that goes through deep brain stimulation, and also it's beautiful to see the reactions of the son of our team members, that is our guinea pig, to test all his behaviors and how he reacts to the movies that we are showing him. And once again, we are designing the movies, so they're not watching any movies because we're trying to create the stimuli that science has shown. And the bottom line is, and I always joke that maybe it's because I'm getting old, but we want to bring all the science that we know at Duke and that we have access to as privileged people. If you are in this room, you are already on the privileged class, just by being here. And that's a small minority of people. And we want to bring our knowledge that most of us might not need because we do have access to privileged doctors, how we bring it to the masses. But still, and I can tell you a lot of anecdotal examples of people with MDs. There was an article in the New York Times a few years ago with one of the top autism researchers in the country missed the signs of his own son. Okay? So even people that have access to good medicine, this is not easy to diagnose. And the way we started is I went to Helen and Jerry and say, if you give me 20 seconds, what will be the first thing you're going to do? And she said, if I only have 20 seconds to check if a kid has signs of autism, I will ask the mom to call his or her name and see if he turns. So now we have that in the app. The mom calls the name or the nurse, and we automatically code that. And it wasn't easy, but it works. It works 100% of the time. So it's technology that we're pushing in other disciplines, but I want to go back to the beginning, that engineering is not what it used to be. So when I'm joking, I have a son that is a senior and another son is an 8th grader. And I said, I didn't have email when I went to undergrad because I was too young. You had to be like a senior to get email. It was very limited. And when I was a postdoc at MIT, somebody said, have you seen this? And show me Netscape. Do you guys know what Netscape is? The first ever browser. And I said, wow, that's very cool. Okay? And that was not even on beta, it was just trying. And that was also engineering. And if you come to Duke, you're going to see that we all work with MDs or we work with social science people. Our building grows. We're on the 3rd floor. 2nd floor is Social Science Research Institute. And basically, we have shared offices. Helen and Jerry have an office right next to me. So in a kind of an engineering department, you have 2 psychologists and psychiatrists coming out once or twice a week. I mean, I'm just one of many. I'm almost everybody. The last part, and once again, if I pull together the team that we're doing the psychology, that team goes all the way horizontally and vertically. Horizontally, we have people from almost every department that you can imagine. Vertically, we have undergrads, grads, postdocs, MDs, and we actually even have now a high school from North Carolina, math and science, that join our team. So I have about 5 or 6 undergrads during the year working with me, which is something that is very common at Duke, that we have undergrads coming to our teams. Because these areas are so broad, there is something for everything. So this North Carolina kid from math and science is helping us to make the videos that we did much more professional. So these are puppets, and we used to see the arms, and now we don't see them anymore. So he's actually helping us to move from amateur to professional. And that's what he's doing. He's so bright, actually, that was his job for the semester, but he's about to be done, and we're in September. So we're trying to figure out what he's going to do next. And he's only coming like twice a week. So as I say, we integrate horizontally and vertically. And the meetings on Wednesday morning are just a lot of fun because of that. So that's engineering today, is basically working with people. And not just, and you're going to see, I had students that were double majors, engineering and dance. We made a very cool project. I had last year in my class a guy that was double major, double E, and music. So that's not uncommon to see at Duke. And that's what I think, as I say, just to close how I started, that's what attracted me to come here. Just to be able to work with people and keep learning and try to make my own small contribution. I hope you get a bit of the message. I'm going to make sure that they got my presentations and you go and see them. We have, if you want to see what deep brain stimulation is, just Google. If you want to see results of our children, actually there is a foundation which is called the Simons Foundation. It's one of the foundations that supports a lot research in autism. And they actually made a very nice popular science note about our work. So if you look at computer vision helping autism, Simons Foundation, something like that, you're going to get videos from our work. Some of the videos that I was planning on showing you, they really wrote a very nice piece a couple of months ago. But as I say, my goal was to talk with you 10 minutes and then get questions. We got delayed, but I wanted to see if you guys have any questions before. I think you need to go to lunch after this or something like that, so we can be a bit late or something like that. So any questions? Yes, please.
Can you just spell the name of the foundation?
Yeah. It's almost like Simon Says. Oh, okay. So it's simons.org. And the foundation does a lot of things, but there will be a link there to autism. Simons is the co-founder of Renaissance, one of the largest hedge funds in the country. He has a foundation. I'm not advertising his foundation, but they work so hard into this small note that I think is very good to illustrate one of the things that we're doing in my team. Yes, please.
Could you explain a little more about how you were able to kind of zero, how your work enabled them to kind of zero in on the spot where they needed to apply the electrodes?
Yeah. So what happens is that we first show that, so I'm just going to become geeky for 1 second. In the hospital, there is a machines called MRI, magnetic resonance imaging, and the power of that is up to what's called 3 Tesla. So that's how strong the magnet is. You have to think a Tesla is $1 million. And we started working with this with colleagues that have 7 Tesla machines. So that's the $7 million. And we develop a protocol that if you go inside a 7 Tesla machine, we see it. We just see it. The neurosurgeon say, wow, this is the first time in my life that I see what I'm doing in my patients. So you actually see it. So we developed that. We developed some image processing algorithms, and we can show it to them. And then we say, OK, this is great. At first, it's not a big deal. You fly to a center with a 7 Tesla. There's about 50 of those in the world. It's maybe a few $1,000s extra to your 120. But that's still very limited. And then we say, OK, what happens if we do big data? What happens if we enter enough patients on those 70 that instead of having this histology atlas of one lady, we have a lot of images? And then part of the image processing and some machine learning that we do, when a new patient comes in, they send us the data from the hospital, and we match that patient to our data. And we say, this is your closest brain. It's actually not one, it's a set of brains. And we do a prediction. And we say, based on what we have seen in the past, and based on your brain, this is where you should go. And what we have demonstrated is that we hit all the time with that, which is basically are there all the time. So that basically says, if you have access to a 7 Tesla, we give you the Ferrari surgery. If you don't, we give you a Lamborghini. But you were actually on a bike before that. And I applaud the neurosurgeons and neurologists. And the reason they are awake is because they want to see your reaction. So they poke there, and you stop tremor, or you don't. And they're very worried about side effects. So some of the areas that are next to it, like the red nuclei, if you touch it, you start seeing blurriness. So the patient has to be awake. Actually, they're reading. And surgery can go for 5 hours, so it's not very nice for the patient to be awake. So that's how we do it. We have this cumulative knowledge that with that, we combine both things and we say, this is where you need to go. OK, I want that question, and then I want one of a potential student. Just stand for your group.
How widespread is this technique going to be used?
Which one of both?
For narrowing in and getting technology.
So let me just, for the deep brain stimulation, we actually have licensed technology. There's a company involved, and there's hospitals that are signing in to do testing. So that's one. The other, we are starting like research to start. We testing in a clinic, we step 1 step forward. But our plan is just to put it on the web and just people be able to download without even telling us. But going back to big data, we also want people to, if they volunteer, to give us their videos and their feedback. Because in child mental health, so the largest studies, so Helen has the largest study of anxiety in children. It's about 1,000 children. It's big data, but it's not enough to understand everything. So we believe that with this, we might be able to go back to learn more about the disease and then feed that back. So we want to close the loop. Today, we're putting out there what our knowledge tells us. But hopefully, by seeing hundreds of thousands, we will learn more from them and then keep improving the technology. And this is the only way. The only way to get to large numbers is to do technology that everybody can use. Otherwise, count the number of hours an MD has to attend. They won't see. They see a couple of thousand in their lifespan.